Today, we're diving into the critical and honestly fast-moving world of diagnosing fungal infections without having to rely on traditional culture methods. For any patient who's immunocompromised, getting this right and getting it fast can literally be the difference between life and death. All right, so here's our game plan. First, we're going to tackle the core problem, why the old ways just aren't cutting it anymore. Then we'll walk through the tools we can use right now, everything from what we can see under a microscope to detecting the fungus's footprints and its DNA. And finally, we'll tie it all together with clinical strategy and, of course, the absolute essentials you've got to know for your exams. So let's start with a situation that every clinician dreads. You have a patient whose life is on the line, and the diagnostic clock is ticking way faster than our traditional methods can ever hope to keep up. So I want you to picture your patient. They're immunocompromised, they're critically ill, and you know that every single hour counts. You're suspecting an invasive fungal infection, but you have zero time to waste. The clock is ticking, and the decisions you make right now will have immediate, life-altering consequences. This is the million-dollar question, isn't it? It gets right to the heart of the problem we need to solve. The so-called gold standard of culture, well, it has some serious and often really dangerous drawbacks in these urgent situations. And this slide lays it all out. I mean, first off, 2 to 4 weeks for a result, that's an eternity for this patient. But it's not even just about the speed. Think about this. What if the fungus in the sample is already dead because of the initial drugs you gave? Or what if you just couldn't get a good sample from deep inside the lung? In both those cases, the culture will come back negative. It's a false negative, and it leaves you totally flying blind. So let's pivot to our first line of rapid investigation, actually looking for the culprit directly under the microscope. We're talking about getting answers in minutes, not weeks. Think of this as your immediate microscopic toolkit, and each stain has its own job. A 10% KOH prep? That's the simplest. It just dissolves our own cells, making the fungal elements pop out in something like a skin scraping. But for a much better look, especially in tissue, Calcofluor white is amazing. It binds to the chitin in the fungal cell wall and makes it light up under UV light. It's like putting the fungus under a black light. The India ink stain is just a perfect example of a rapid, really elegant tool. Because the ink particles literally can't get through that thick, gooey capsule of Cryptococcus, they create this beautiful halo effect. If you see this in the spinal fluid from a patient with meningitis, well, that's a classic finding, and it means you can start the right treatment almost immediately. Okay, so what if we can't actually see the organism itself? Well, our next move is to look for the biochemical clues it leaves behind. You can think of these as the fungus's footprints circulating right there in the patient's body. Now, this is a really key distinction to grasp. Antigen tests, which detect actual pieces of the fungus, are our go-to for early aggressive disease. This is especially true in immunocompromised patients. You know, the very people who can't mount a strong antibody response. Antibody tests, on the other hand, they're measuring the host's reaction, which makes them more useful for chronic infections in people with a healthy immune system. Okay, this is a critical slide. Seriously, this is your high-yield summary of the big 3 antigen tests. If you suspect Aspergillus, you're ordering a Galactomannan. If you're worried about Cryptococcus, especially in the CSF, CRAG is your test. It's incredibly reliable. And then you have β-D-Glucan or BDG. Think of this as your broad net. It detects the component in most fungal cell walls. But, and you have to remember this for your exams, it has 2 major blind spots. It will be negative with Cryptococcus and with mucormycosis. So, we've looked for the organism and we've searched for its biochemical footprints. Now, let's go a level deeper and look for its actual DNA. We are now entering the world of molecular diagnostics. The power here is all about speed and precision. Real-time PCR doesn't just give you a yes or no answer. It can tell you how much fungal DNA is there. That's huge for tracking how well a treatment is working. Then you've got game changers like the T2 Candida panel, which can find fungal DNA directly in the blood, completely bypassing culture. And you know, even if you do get a culture, MALDI-TOF can give you a species-level ID in minutes instead of days, which is critical for picking the right drug. But look, these powerful tools, they're not a magic bullet. Their incredible sensitivity is kind of a double-edged sword. It means there's a real risk of picking up contaminating DNA, which can lead to a false positive result. They're also more expensive, and they definitely require some specialized expertise, which is why we have to be smart and strategic about when we use them. So how do we put all of this information together? A single test result is just one piece of a much larger puzzle.
The real skill is weaving it into the full clinical picture to make the right call for our patient.
And this is where your clinical judgment is absolutely essential. A test result is never a diagnosis all by itself. So you get a positive β-D-Glucan. Is it a life-threatening infection, or is it contamination from a dialysis filter? You get a positive Aspergillus PCR from a lung washing. Do you have invasive disease, or is the patient just colonized? You see, context is everything.
So here's how it all comes together in a practical, real-world workflow for suspected aspergillosis. You start with your high-risk patient. You immediately send samples for those rapid biomarkers, the GM and the BDG, while at the same time, you're getting a direct look at the lung fluid under the microscope. The results from those first tests then guide your next step, which might be a highly specific PCR test for confirmation. It's this multi-pronged attack that gives you the best shot at a fast, accurate diagnosis.
Okay, let's boil all of this down. What's the most important, high-yield information you absolutely need to take away from this, both for your exams and for your clinical practice?
If you remember nothing else about antigens, remember this. Suspect Cryptococcus? Order a CRAG. Suspect invasive aspergillosis in a patient with no white blood cells? Order a Galactomannan. Need a broad screen for a possible fungal infection? Use β-D-Glucan, but always keep its limitations in the back of your mind.
So think of your molecular tests as your specialized tools. When the clinical picture is screaming fungus, but your initial tests are negative, PCR can be the tiebreaker. It's also a lifesaver for identifying weird fungi that don't grow well, for tracking treatment response, and for getting a super fast species ID from a blood culture that just turned positive. That can tell you if you're dealing with a simple Candida albicans or a much more resistant species, days sooner. And this comparison, right here, really drives home the core message of this whole explainer. I mean, just look at the difference. We are completely transforming diagnosis from a process that takes weeks into something that takes a matter of hours. That is the power of non-culture-based diagnostics. It lets us act decisively, right when our patients need it the most.
And that leaves us with one last really crucial thought. As these non-culture tools get better and better, what happens to the good old-fashioned culture plate? Well, while it might not be our first stop for a rapid diagnosis anymore, its role is far from over. It is still absolutely critical for giving us a live organism. We need that isolate for definitive antifungal drug testing, for understanding resistance, and for tracking outbreaks. So the future isn't about replacement, it's all about smart integration.